Good day, everyone. Today, we're diving into a foundational chapter for any research project, Chapter 7 Instrumentation. As the quote often attributed to Peter Drucker goes, you can't manage what you can't measure. In research, you can't study what you can't properly measure. This chapter is all about how we get our data and the tools and the critical standards we use to ensure they are effective. At the end of this session, you'll be able to define instrumentation, identify various research tools, and understand the crucial part for data collection. Most importantly, you will master the core concept of validity, reliability, and objectivity. We will also explore how to find, develop, and test these instruments to ensure the success of your own research. The house of research. Instrumentation refers to the entire process of selecting, developing, and using tools to collect data. Data is a piece of information collected to answer research questions. Instrument, the specific tool or method used to gather the data. And key concept, the quality of your instrument directly determines the quality of your data, and therefore the credibility of your findings. The researcher's toolkit. The researcher's toolkit is diverse, and the tools are often categorized by their methodology. On the quantitative side, where we deal with numbers, we have tools like standardized tests, like SATs, research-made questionnaires, attitude scale like Likert scale, and the checklist. On the qualitative side, where we deal with words and meaning, the tools are more often narrative. They include interview protocols that guide a conversation, observation schedules for taking, field notes, and templates for documents or content analysis. Before we even hand out our first survey, you need a meticulous plan. Frankel and Wallen stress that the logistics matter. You must answer several key questions. 1. Where will the data be collected? In the classroom, online, the setting can influence responses. Another is when and how often. Is it a one-time survey or a pre-test or post-test design? By whom? Who will administer the instrument? The researcher, the teacher. This person needs to be trained to ensure consistency, which is a concept we'll return to. Standardizing these procedures is not just about organization, it's a fundamental part of maintaining the integrity of your data. How do we know if an instrument is any good? We evaluate it against three non-negotiable criteria, the three pillars of a good instrument. First, validity. This is the big one. It asks, are we actually measuring what we intend to measure? Is your math test really testing math skills? Or is it just testing reading comprehension? It's about accuracy, hitting the bullseye. Second, reliability. This asks, are we getting consistent results? If you weigh yourself on a weighing scale 5 times and got 5 different answers, that scale would be unreliable. Third, objectivity. This asks, are the results free from the scorer's bias? Would two different researchers interpreting the data arrive at the same conclusion? This is crucial for scoring essays or using observation checklists. A good analogy is a bathroom scale. A valid scale accurately measures your weight. A reliable scale shows the same weight even if you step on and off repeatedly. And an objective scale gives you the same reading no matter who uses it. Now let's dive deeper into validity, the most important criterion. It's essential to understand that validity is not a property of the instrument itself, but of the interpretation and use of the scholars it produces. A test might be valid for predicting college success, but invalid for diagnosing a learning disability. It's about the evidence supporting our inferences. We gather this evidence by looking at the different types of validity. One is content validity. It is about coverage. Does the question on your instrument adequately represent all parts of the construct you're studying? For a final exam, does it cover all the chapters taught? This is typically judged by experts in the field. Another one is criterion-related validity. It is about correlation. Does your instrument's score predict or correlate with a current or future outcome? Now, there are two types or forms for this. One is concurrent validity, where it correlates with current criterion, like a new depression scale matching clinical diagnosis. Another is a predictive validity, where it forecasts a future result, like the SAT predicting first-year college GPA. Then we have the construct validity. It is the most comprehensive and theoretical. It asks, does this instrument truly capture the abstract, theoretical concept it's supposed to? For example, does a grit scale truly measure the construct of grit and not just conscientiousness? Establishing this requires a network of evidence. Now, two other concepts are worth mentioning also. Face validity is the simplest. It just asks if the instrument looks like it measures what it's supposed to. It's not technical evidence, but it's important for gaining the trust and cooperation of your participants. Another is consequential validity. It is an ethical consideration. It forces us to ask, what are the potential consequences of these test scores? Could they unfairly label students? This reminds us that our research tools have a real-world impact. Now let's turn to reliability, which is all about consistency. A reliable instrument yields similar results under consistent conditions. There's a critical relationship between reliability and validity. An instrument can be reliable without being valid. Imagine that a broken scale consistently tells you you're 5 pounds lighter. It's reliable, consistent, but not valid, accurate. However, an instrument cannot be valid without first being reliable. If you can't measure consistency consistently, you certainly can't measure accurately. So how do we measure reliability? There are three common methods. Retest reliability. You give the exact same test to the same group after a time interval. A high correlation between the scores indicates stability over time. Then we have equivalent form reliability. We create two different but parallel versions of the test and give them to the same group. A high correlation shows consistency between the forms. Then we have internal consistency. This is very common in survey. It checks if all the items in the single instrument are measuring the same underlying construct. The most common statistics for this is the convex alpha, a number between 0 and 1. Generally, a score above 0.70 is considered acceptable, indicating that the items hang together well. Now, when human judgment is involved, like scoring essays or observing behaviors, we need a specific type of reliability called inter-rater reliability. This is how we ensure objectivity in action. The process involves training multiple raters using a clear, detailed scoring rubric. Then they independently score the same test, the same set of responses or behavior. We then calculate their level of agreement using statistics like percentage agreement or the most robust Cohen kappa. High inter-rater reliability means that the instrument is objective and not dependent on the whims of a single scorer. This classic target diagram perfectly illustrates the relationship. The top left is rare in practice, high validity but low reliability. The average is on target, but any single measurement is unreliable. The top right is a consistently wrong scenario, low validity but high reliability. The shots are tightly clustered, but they're all missing the bullseye. The bottom left is our nightmare scenario: low validity and low reliability. The results are all over the place, inconsistent and inaccurate. And finally, our goal is high validity and high reliability. The results are consistently accurate. This is what we strive for in our instrumentation. When you need an instrument, you have three main paths. First, using an existing instrument. This is often the best first step. The pros are huge. The instrument likely has established validity and reliability. It saves you time, and it allows you to compare your results with other studies. The con is that it might not be perfectly fit in your specific context. Second is modifying an existing instrument. A word of caution here is that changing even one word can alter the meaning and psychometric properties of a question. If you modify an instrument, you must treat it as a new one and re-establish its validity and reliability through pilot testing. Then the third one is creating your own instrument. This is time consuming but it allows for a perfect tailoring to your research question. The major drawback is the heavy lifting required to prove its worth through rigorous validation. Now this brings us to a step you should never skip: the pilot testing. This is a small-scale dress rehearsal of your entire data collection process. The goal is to identify ambiguous and confusing questions, to check your timing and logistics, and to collect initial data to run a preliminary reliability analysis like calculating convex alpha. The feedback from a pilot test is invaluable. It allows you to refine your instrument before you launch your main study, saving you from a potential fatal flaw in your research. To summarize, instrumentation is the backbone of your research. Your choice of tool must be driven by your research question. You must plan your data collection with meticulous care. You must evaluate your tool against the golden standards of validity, reliability, and objectivity. Remember, the credibility of your entire study rests on the quality of the data your instruments collect. A brilliant research question can be ruined by a poorly designed survey. Thank you, and I am Marlene Wong, your discussant for Chapter 7, Instrumentation.